Greg Dannenhauer here at Parker Boiler. We've got two TC600L low NOx units equipped with our canister burner and a Siemens LMV control system for 9 parts per million NOx. This is called low NOx system number 6 at Parker Boiler. The elements of it are this canister where the 2 horsepower blower discharges fan and it's mixed with the inlet gas through a canister where there's mixing tube inside this. This is the final LMV modulating control valve, which will allow us to fine-tune the boiler for exact fuel-air ratio control. This is the burner. It's called a PB33, which can go up to 3 million BTUs. It's a metal fiber burner with a metal fiber material. We run this about 30 to 40% excess air to get the low NOx numbers. On the control panel itself, there's some typical Parker items and then there's some special items. I'm going to identify those. We've got our Parker Light sequence indicating system, control power, water level safe, limit safe, pilot on, and burner on. One thing, when you do use the Siemens LMV, you have a AZL display and there is a safety loop off of that. So every limit failure will not necessarily knock that limit out. If you do have a safety loop failure on the LMV, it will be enunciated here. On the operating modulating control, we're using the Siemens RWF55, which is Modbus connected to the touchscreen. This touchscreen is an add-on item which gives you more information and actually displays in simple text and nice graphics what's occurring during the boiler operation. Additionally, on this boiler, you've got our VFD where you can see the speed through the window, manual reset high limit at this point. The control switches look the same on most Parker boilers. Boiler control switch, manual reset and test button for the low water. There's a main burner switch, and this has a local remote so that the set point could be varied by someone on the outside. The scanner eye is on top of the burner, and there's a viewport sight glass over here. So let's go through a startup on this boiler. As we start it, there'll be a call for heat, and what happens is the AZL displays the phase of the Siemens system. The first one is phase 24, which is reiterated up on the touchscreen. It's switched to pre-purge, and it gives you a time at high fire to clear the combustion chamber of gases. The next startup sequence will drive to low fire, and then we'll start off. The phases show here and are enunciated up on this touch. Also, there goes our pilot, phase 40. With the proven pilot, main burner comes on. Tells you your fuel valve is open during the safety time, proof of flame. Also on this touchscreen, now the burners come on. We've got gas firing rate 15%, flame signal at 100% now, VSD speed, which is the variable speed drive, and the fuel valve position, which is indicating how much fuel is going in. Also, the set point and the actual value are also reiterated or carried over here from the RWF55. One feature of the RWF55 that's very handy is you hold the escape button until you get a hand. This is now displaying the percent modulation. That means the VFD speed and this burner flame are going to progress to low fire, which I believe is about 24 hertz on this blower. Note that the LMV gives us the ability to light off at something other than low fire speed, and it gives us the ability to increase the fuel rate or richen the mixture for light off. This is why we've gone to it on the 9 ppm boilers. Right now the outlet water temperature is 82 degrees, and that's reiterated over here on the actual value on the touchscreen. So this is a add-on item to the standard LMV system. Okay, here we are on the side of this boiler. The boiler is still going through its 2-minute post-purge, which is a good idea to remove as much gas and cool off the vessel the best we can and move the air through. This is our hot water supply. We normally provide an angle so that we can put our low water probes on the vertical position, temperature, pressure gauge, auxiliary operating control. On this side is the location of the manual reset high limit, which is right in the vessel. The RWF55 sensor, which is a J thermocouple, is directly opposite in the boiler shell itself. So here's the position of the relief valve. This is your high temperature return, and this is your low temperature return up top of the boiler. On the back, there's a few items going on. We have our boiler drain, which is the boiler water drain. We also have our condensate drain, which is draining from this flue gas collector chamber. Through this flue gas collector chamber, there's condensate which drains here. We trap it to hold the pressure and not allow the flue gases to escape here, and this will go into your condensate neutralizer. There's one probe in here such that if the water overfills to, say, this level, that's going to cut you out. Additionally, on the back, another UL requirement for condensing boilers is a flue gas pressure switch. So this is sensing a blocked flue. It will lock the boiler out. The back of this boiler, a very convenient inspection point. You can get in here, inspect the back of the boiler. You can feel around. You can see there's a little water in here at this time, but you're going to get a real good, you can really do a very good inspection of what's going on in the boiler simply by pulling this inspection port, which goes back on pretty simply, screws into place.